Buongiorno a tutti. Eh, sono Luca Bongiorni, come mi hanno presentato sono il direttore del Cyber Security Lab di ZTE Italia e purtroppo, ahimè, anche il Chief Security Officer per l'Italia. Dico purtroppo perché c'è un motivo. Adesso farò una domanda a riguardo. Allora, prima di tutto, quanti di voi conoscono il termine CSO o CISO? Chief Information Security Officer o Chief Security Officer? Ok. Quanti di voi hanno mai conosciuto o sentito almeno parlare del CPSO, Chief Product Security Officer? Ecco, uno. Ah, ha vinto. Devo dargli il cookie. I have to give you the cookie later on. Ecco, questo è un problema che è a monte di tanti altri problemi e uno di questi è il SecDevOps. Per ovvi motivi so che in sala c'è qualcuno che non capisce l'italiano, quindi switcherò in inglese. So I will switch in English in order to let people that cannot speak Italian to understand as well. So, where we start? How many of you, quanti di voi conoscono il concetto di DevSecOps o almeno DevOps? Ok, ci siamo. DevSecOps è quell'insieme, quel gruppo di attività, processi, serie di test, serie di tasks che coinvolgono tre differenti entità. Sorry, I will switch back in English, it will be easier for everyone. So, DevSecOps is a term composed of development, security, and operations. Usually, companies that develop products, most likely software, that's how it started, from software point of view. They realized many years ago that they have to be agile. So waterfall schemes doesn't work anymore. They need to be, as it says the word, agile, in a way that the faster is developed a new feature of a product, the faster it goes to the market, the happier is the customer, right? However, when they started adopting DevOps, development and operations merged together, so for each iteration of an agile process, architects design new feature, developer develop new feature in this software, and then get tested by QA, performance team, and then released to production. And this goes on and on for new features of the same products. That's the DevOps. However, soon companies like Microsoft realized years ago that is not enough. We need to implement security. We need to do product security. And that's why they implemented SEC inside dev, between dev and ops. This presentation will be about how, from the perspective of my employer, SecDevOps or DevSecOps should be implemented, or this is at least our way of doing things. I hope after this presentation you will get some new ideas that you can bring back to your company, or if you're a consultant, to your customers in order to improve product security in Italy. That's why I asked at the very beginning how many of you heard about Chief Product Security Officer. At this moment in Italy and Europe, mostly in US, there is a person, an executive level person, that takes care of the products of the security of their products. Right now, in Italy and Europe, we have difficulties to have such level of executive. Usually there is a director level, higher manager level product security person that reports to CTO, CIO, and so on and so forth, but doesn't have the leverage and the jurisdiction and the power to improve and to seek and get approval for more budget to improve the security of the products that a company sells. This is a critical point, because especially with the CRA, Cybersecurity Resiliency Act, from one side, and from another point of view also the NIS2 directives from UE, or European Union, we will see more and more end users, customers, governments demanding that products meet a certain level of security standards. So first of all, cybersecurity, as we all know, probably in this conference, this is a cybersecurity conference, is a growing concern for everyone, every sector. That's why in Italy, for example, we have the PSNC, Perimetro di Cybersicurezza Nazionale, That's why we have the directives from European level, like NIS2 and so on, CRA and so on and so forth. So everyone is impacted, not only critical national infrastructures, but literally everyone. From that point of view, ZTE took already from many years the idea to embed security in each part of the life cycle of its development, products development, both software and hardware. Here we can see the pyramid of the ZTE cybersecurity mission. The idea is to bring together experts like me. For example, I'm beside the CSO of Italy. I'm also director of cybersecurity lab in Rome. We brought together different experts from different fields, from different nations, in a way that we can cover at different level of the life cycle, the security of the products. If we look from a DevSecOps perspective, DevSecOps is not easy at all, in general, for any sector, because we need to bring DevOps closer, or better, bring security very close to DevOps processes. Implementing security in DevOps is hard, because you need to automatize many processes. Already automated processes that are dealing with dev, like CDCI pipelines, continuous integration, continuous development processes, pipelines, you need to embed security in it. So in each phase, we will see in the next slides, it's not easy and tricky. In telco, in telecommunication, it's not any easier. If you ever looked, how many of you are coming from telecommunication industry? 1, 2, okay. 3. You know probably how painful it is dealing with telecommunication, especially, okay, now we have 5G, 4G, 3G, okay, 3G is almost that, 2G and so on. And then soon we will have 6G. If we take just one of these G, like, I don't know, 5G, and you split down how a network is composed, like core network, RAN, and so on and so forth, and we split again these groups in smaller entities, we will see that there are tons of appliances that can be hardware, like servers, or machines, like BBU or RUs, radio remote units, or software. Now we have the concept of Kubernetes, Dockers, so Dockerization, so virtual machines at a certain level of pods that are all different entities, different assets. Now they are of this infrastructure, technical infrastructure, are working in the same data center or in the same big server. For dealing with the security of those, especially in development, we need to use security, the concept, as it would say someone that is an architect from US would say shift left. You need to move as earlier as possible the security in a way that you can mitigate problem even before they will appear in the code. So SecDevOps is not any easy. In Telco is not any easier. If we look from process point of view, how we split the problem. So we thought, okay, we need to implement security in each phase of the development life cycle. We want to have it automated in DevOps, so apply SecDevOps. Where we start? Well, first of all, the first layer here on the top, we can see that we start with regulations and standards. So there is NIST, there is European Union, GSMA, ETSI, all these companies, all these organizations, especially GSMA and ETSI, are those organizations that develop telecommunication standards. For the telco guy here, they know by memory. For the others, those are the groups, work groups, organizations that define the specifications of each part of each protocol embedded in the 5G, for example. So those are the authorities. Then we have, of course, in ESA, the European level, NIST in US, and the worldwide, and other ISO, for example, standards. So we take all these regulations from different actors and organizations, we study them, and then we take the requisites, security requisites, and then try to implement down in the line in our processes. From one side, we have the processes of development. In our case, it's called HPPD, which is a high performance program development. You can see it as a secure software development life cycle. So we took the concept developed by Microsoft 25 years ago of secure SDLC, so secure software development life cycle, and then we improved it and implemented in R&D. From the other side, we follow technical standard systems, like all the regulations that, where were found in the first level. And down, at the very end, we implement them with the supervision of security teams nearby the product line, so the R&D teams. This is okay, probably from there you cannot see from the monitor, maybe a bit better. But this is the whole HPPD process. So this is our secure software development lifecycle. That's how it works. We try to implement, as I mentioned before, security in each phase of the development of the product. So we start with the concept, and with the concept goes the security requirements. With planning or design, we do apply security design, like threat modeling, risk analysis and mitigation, and so on and so forth. At the development phase, it should be very clear which could be the threat for this specific software in a way that they can be either addressed in advance or mitigated before the code is written. In a way that at the very end, we have a prototype software product where, of course, QA, quality assurance, performance, and of course, security tests are done. That's one of the things we do in the lab in Rome. We do security tests from both software and hardware. And then eventually, once the product is released, as you know, if someone will tell you that a product is 100% secure, either he's an idiot or he's trying to sell you smoke. There are no products in the world that are 100% secure. Even the military one, no one. Can be secure for a very short time frame. Let's look at cryptography. DES was safe 30 years ago. 5 years later was already proved, mathematically speaking, that can be broken. A few years later was proved impractical. Then they added the 3 DES as encryption system, but that was just applying DES 3 times. So it was mathematically harder, but then it proved that can be broken. Then they created AES, and then AES 128, AES 256. Those are still valid, AES 256, but eventually with the quantum cryptography and quantum computing, those will be broken as well. So it's just a matter of time. In a certain time frame, that specific product can be secure, but we will not know in 1 year or in 2 and so on and so forth. So what we are doing is trying to implement security in all phases. And especially we rely on tools, security tools, either commercial or on-premise, in-house made. So we make by ourselves. And we can see that there are different tools that solves different problems. Threat modeling, source code scanning, vulnerability scanning, web fuzzing, protocol analysis, protocol fuzzing, and so on and so forth. How these tools are picked, we will see in the next slide. The idea is that we have, this is the cybersecurity governance structure. The idea is to have, regarding product security, we divided the product security in different lines of defense. We have the first line, where there are like the security teams very close to the product development teams. So we have supply chain security team, we have global cybersecurity team, so the lab in Rome is part of the global. We have evaluation teams on the second lines, and so on and so forth. And then we have the third line, which is sort of supervisory team. So they do the supervision. So practically, they're just checking if the other 2 lines of defense are doing a good job. If they're not doing a good job, they will report to the committee, which is the Cybersecurity Central Committee, and then they will, those people that do not perform well or do not follow the processes that were defined will have to fix those problems. But here, this slide is mostly to show you that to deal with tools, security tools in SecDevOps, there is a special task force. This special task force is composed of 3 different types of people, groups of people. The first group is coming from the first line, the second group from the second line, and the third group is coming from other teams, like dev teams, QA teams, performance teams. Altogether, they form the joint team for security tool. And what this team does, besides drinking coffee, well, they meet together, they analyze new requirements coming from ENISA, let's say, or coming from new regulations, Italian level, European level, worldwide level, or requisites, requirements from the customers as well. And they say, let's say, okay, we are going to deploy a new 5G RAN on customer X in Italy. We want to be sure that the communication of some specific protocol is secured or is configured properly. how can you prove that? So then they evaluate if we already have a tool, commercial tool that does that. If we don't have, we start to look, this group, this joint, how is it called? The joint team for security tool evaluates if there are tools out there available, commercial, that we can purchase and test. If not, they start planning developing their own. So this is practically the type of function that should accomplish this kind of tools. That can be anything. And they are divided by properties. So like, for example, if you look from index technical function, then and we want a tool that does code review, we want to know which kind of languages it supports to do security code review. C, C++, Java, Python, call it just any. If we look from case studies point of view, still have 6 minutes, I can do it. If you look from the second telco case, this is one of my favorite, threat modeling. How many of you heard about or has done threat modeling? That's sad. You should go back home and study what is, because in US they are like 20 years over us on this. Threat modeling is not risk analysis. It's very close to the concept of risk analysis, but usually you do it to identify the threats. Not the vulnerabilities, but the threat. So usually vulnerability, okay, imagine, usually I use a slide, very, very simple to understand. Imagine that outside this door, or window, whatever, there is a bear. The door is open, so the bear is the threat. The door open is the vulnerability, and the risk that the bear will come inside and kill me, it's the risk itself, right? So threat modeling is used to identify the threats. The threats comes before vulnerabilities. Vulnerabilities goes once the product is developed. The threat comes at the design phase. So if you do threat modeling at the design phase, you save time to developers in a way that they will know what to not develop, so not develop vulnerable code, and you will save a lot of time to customers, to testing teams, because they will not find vulnerabilities related to these threats. So threat modeling is a critical component to save time and money later on. How is done inside the company? Well, we gather a lot of stakeholders from different entities, security architecture, product development, security teams, and it's exactly the security teams that they start the threat modeling of a product by doing a security design checklist. So they check the features of this product. They talk with the project manager, the future developers, the architects, and ask, what feature will have this product? Does communicate with some network? Which protocol? Which ports will be open? Which services will run? And depending on all these questions and answers, they will define what could be the threat for one or more of these properties, services, ports, protocols, and so on. Once we have potential threats, we gather with other teams, we evaluate together if we missed some threats, and then there is a full group review with more developers and other people involved in this product. Everything is filled in a framework, software framework in-house developed called ZTE RD Cloud, which imagine that is a huge database with all possible threats for all possible products. So in case you missed one threat on your product, you can double check if it existed in other products. And maybe if the two products are quite similar, you can see the blank spots that you missed. So you can add even more threats on your threat model. Once it's clear what are the threats, then you pass over everything, you pass to the development phase, and developers will take care of that in a way that will avoid to create this kind of threats. And then, of course, later on there will be like prototypes, after the development of the first phase, and then testing at different levels. So they will test at the evaluation team, we will test in the cyber lab, and so on and so forth. Another case is customized continuous integration pipelines. What that means, to keep it simple, imagine that you create the very first alpha version of a release of a software. You do a certain kind of checks, most likely not very security related. These are mostly QA and performance. Once they pass all these tests, so the software release is stable, it moves to another continuous integration pipeline. The more we move to the right, the more we will end up to the final CI pipeline. So the final pipeline that then will create a new release. for the product to go to production. At the very end, once everything is passing QA and performance, security scans are done. So automatically, for each release, are done like system scanning, virus scanning, auto-regression on vulnerabilities. So that means that if in version A was found a vulnerability, the, the vendor was notified, product security incident response team took care of it, triaged it, dev team fixed it. That means that there is a new release. Then, in the third release, so release number C, they will do check again if that old fix is still there, or if that old vulnerability has been fixed. In a way that by switching with new release, we don't miss patches that were done in before. Sometimes happens that the same product goes to different customers. Different customers have different customization requests. So that's why it's very important auto-regression. In a way that all the customers are happy and they received a new version that doesn't contain a vulnerability that was found in another customer version, and it gets fixed as well in their version. And then, of course, our open source scanning. SBOM, single software bill of materials, is a very hot topic, I would say, in the last years. So software bills of material is very important because we know that many vendors are using open source libraries. And those open source libraries are very sensible to vulnerabilities. 0 days are popping out any time for any library out there, right? So we need to be sure that we track which open source libraries we are using for our products. No tracking, no visibility, no transparency, we are all screwed. Both us as manufacturers and customers that may end up with a vulnerable version of a product, not because the code that we wrote is vulnerable, because the dependency, the third-party open source dependency was vulnerable. This is a tool developed in-house. So in that case, for some features, it was not possible to find commercial solutions, tools for doing those kind of testing activities, like, for example, fuzzing 5G NR. If you are, some of you that are telco know what is 5G NR. Just to give you an idea, is a 5G related protocol. So there was not a commercial fuzzer that we could buy, so it was developed in-house. This is some sort of how it works, just to give you an idea, the UI. So the Z sniffer supports different protocols for different types of products, like wired products, so wired protocol, wireless protocols, web API, cloud API, 5G. 5G has a lot of, even if it's a telco related infrastructure, it uses cloud, it uses Kubernetes, it uses Docker, it relies on APIs, the classic APIs that we use in web and cloud. So we need a fuzzer to do fuzzing on 5G related infrastructure. And the same we can do for other types of protocol. This is a very simple example. I will not explain because my time probably is over. But just to give you an idea, is an example of in-house developed tool that fulfilled some gaps that in commercial tools we couldn't find. Conclusion, 4 are the main terms to keep up with SecDevOps in telco. Efficiency, SecDevOps improve efficiency. Improvement in general from costs. Even if you need a specific budget, initially specific budget to get started, at the very end, it would save you cost, for less vulnerability found in the products, less time for needed time for testing security products once it's in production, maintenance, and so on and so forth. And of course, it helps with the 2 major, pillars of security, product security, which are secure by design and secure by default. So with these 4 terms, we based our, roots for SecDevOps in Telco. That's pretty much. Thank you.